Hey, so today we're going to start talking about algebra. So we're going to talk today about algebraic expressions and combining like terms. You should have this note sheet in front of you. And when I write, you write, we write. Kind of like I dip, you dip, we dip, right? One of those. Okay, you need to finish these notes with me so that you have a reference sheet. When you get done with this video, you are going to submit us a picture of your notes. So make sure you write them neatly enough so that we can read them. All right, we're going to start right away with number 1. It says, what is an expression that may contain numbers, operations, and symbols? It is, of course, an algebraic expression. And I'm going to have trouble writing here. Algebraic expression. This is very hard for me because I don't have the tools that you do. That's an algebraic expression. Woo! Okay. A variable is a symbol. You already know that. You use variables sometimes in science too. A variable is something that can change. It's usually a letter. Bear with me. I'm not using a pen. I'm using my fingers on the mouse. And that letter stands for the unknown number. Usually it's the letter X. Not always, but many times it is. In terms, number 3, terms are something you learned about last year in 6th grade. They're parts of an algebraic expression separated by addition or subtraction signs. So I'm going to just put plus or minus signs. The coefficient is the numerical factor. And by factor, we mean something that's being multiplied, right? It's the factor of a term that contains a variable. Number 5, variables by themselves have a coefficient of 1. And number 6 says a constant is a term without a variable. It's a constant. So in other words, the number 3 is a constant. It's always going to be worth 3. The number 10 is a constant. The number -1/2 is a constant. Those numbers are always going to have the same value. It's the variables that may change. So as we go down below here, it says label each part of the algebraic expression. So this number right here, this -4, that's the coefficient. I'm going to use cursive because it's just easier for me on the mouse. Coefficient. Okay, that's the coefficient. This letter, oh, I bet you know what that is. It's a letter. What did we just say it's called? It's called a variable. Variable. If you can read this, we're doing well. Just remember, please, it's not because of my lack of effort. It's because I'm using a mouse. This is the other coefficient, the number 3, and the y is another variable. The number 9 has no variable with it, so of course that is what we call a constant. Okay? Like terms. When we talk about things being like terms, we talk about terms with the same variable raised to the same power. Okay? So same variable. When I say same variable, I mean they're both x's or they're both y's. Same variable. Variable. And the same power. Same power. And by power, I'm hoping you know that that means exponent. Okay, while I flip to the next part of this, Please understand why we are giving you these videos of notes. The reason is because you don't really need us while you're taking notes. You need the information, and we're giving you that on a video. Then it frees Mrs. Pearson and I up so that we can work with small groups. That's why we do it this way. So we're back to number 9. It says you can combine like terms to write an algebraic expression in simplest form. Simplest form. When we talk about simplest form, it basically means this: make it simpler. Simplest form. We want things to look easier. So when we simplify it, we make either the variables smaller or the coefficients smaller. Number 10 says the coefficient or constant, take the sign directly to the left of it. This is a big one. I think sometimes we forget where the variable is, where the sign is. If it's a positive on the left side of the number, then it's positive. If there's a negative sign on the left side of the number, then it's negative. To simplify an expression, add or subtract the coefficients of like terms. So you're going to add or subtract the coefficients, the number in front of the variable. You may also need to use the distributive property. We are going to use that a lot this year. I'm going to write it in cursive, distributive. Distributive property. The distributive property you've actually been using since like 3rd grade. Basically means that you're going to distribute a number or a value through the rest of the expression. Now let's try one of these problems together. When you look at all this, it does seem very overwhelming. There's a lot going on here. So let's identify if there are any like terms. I always start with numbers that have powers. So if I have positive 5x squared, I don't see any other x's with a power of 2. So I'm going to just rewrite that. And it's positive, so I don't have to write anything to the left of it. Then it looks like I have a negative 5x and I have a positive 2x. Okay, so if I put together numbers that have different signs, I have to find the difference. You already know that. The difference of 5 and 2 is, what is it? It's 3. But because there are more negatives, it's a -3 or a -3. Minus and negative basically mean the same thing. You're losing. And we only have one constant, which is -2, so I'm going to write -2. That's my simplified version. I can't do anything else with that. But this next problem is a little trickier yet. If this 3 is outside the parentheses, it means there are 3 sets of d minus g. Or I'm taking 3 and multiplying it by d minus g. So this is what I often do to remind myself that 3 is being multiplied by everything here. If I have 3 sets of everything that's in parentheses, that means I have 3 d's, and it also means I have 3 g's. The sign separating the two is a minus, so I write that in. Now I have plus 5g and minus 2d. Do you see any like terms? I do. I always start alphabetically, so D comes before G in the alphabet. So I'm going to circle all the D's. I see a 3D and I see a negative 2D. Do not forget those signs. It changes everything. If I have 3D minus 2D, that means I have 1D left. It is positive because I had more positives. Now I'm going to put a circle around the G's. I have negative 3 G's here and I have 5 G's here. Same kind of situation. The signs are different, so I have to find the difference. 5 and 3. The difference between 5 and 3 is 2. There are more positives than negatives, so I'm going to write plus 2G. And that's what we do.